So first of all, boys, can you please write down the title of this lesson? The Cos Ratio. Can you draw the picture in your book? And can you write the formula here? You might like to pause the video here so that you have these two things drawn in your books. Alright, so we've been looking at the sine ratio and the tan ratio, and in this lesson you're going to be looking at the cos ratio. As you can see in the formula over here, the cos ratio refers to looking at cos theta, but equaling the adjacent length side divided by the hypotenuse length side. So first of all, highlight these on your triangle in your books. So from theta, we see that the adjacent side is next to the theta sine, and we see that the hypotenuse is of course directly opposite the right angle and is always the longest side in our triangles. So we can basically solve for finding out whether we want the angle or one of these sides using this particular formula here. Let's have a look at a question. Can you write this question in your book and draw up this example? You might like to pause the video. Okay, so you should have written and drawn up this question in your book, and now we're going to look at solving this question. It's asking for us to find the angle of this particular triangle using the ratio, the cos ratio. Now, by the way, cos means cosine as well, which I'll just put on the board anyway. Spelt like that and pronounced cosine. There's a bit of information that goes into why we use the cosine ratio, which relates back to the unit circle. But we're just going to use the formula in Year 9 Maths this year to determine the missing parts. So the first thing we do when we approach a question, any question asking for us to use the cos ratio, is actually write the formula down. So we write cos theta equals the adjacent side, or ADJ for short, divided by the hypotenuse side. Then we replace the information we do have, the information in the formula with the information in the question. So theta is replaced with x, adjacent is replaced with 25 centimetres, and the hypotenuse is replaced with 30 centimetres. Then we evaluate our question with the information we can evaluate. 25 divided by 30 on our calculator is equal to approximately 0.83 recurring. Now leave that in your calculator, and we should know that in order to turn our decimal fraction into the angle, we need to use inverse cos, which will then give us our answer. So we must write that working in. That we're finding the inverse of cos, and we see that we get x equals the inverse of cos, 0.83. Alright, now we can then put our answer in, which on our calculator comes up as 33.55, and we can say that x equals 33.50. Check whether you need to round. We've got 55 up, we need to round because the number next to it is a 5 and above, a 7, and we put 56 degrees. We can take this a step further and turn it into degrees, minutes, seconds, which is sometimes found on your calculator as DMS or comma, dot, comma, comma, comma. If you don't have it on your calculator, it is not that important at this stage. But if you do, try and turn it into the degrees and the minutes as practice. So with my calculator, I have degrees, minutes and seconds here. Now my answer won't show it on this particular computer calculator, but on my actual calculator it does. But you'll see the answer is 33 degrees, 33 minutes and 26 seconds. Alright, so I'm writing 33 degrees, 33 minutes and 26 seconds. Okay, so that's accurately recording the angle of that x variable there. Alright, moving on, boys. Can you please draw this next question in? We're going to think of some answers. So here's, find the hypotenuse using the cosine. So if we're finding the hypotenuse, we should have an angle. So maybe let's try 26 degrees for this angle. We want to find the hypotenuse, so let's say this adjacent side here is about 40 centimetres. Can you draw this up in your book? You may like to pause the video. Once it's drawn up in your book, again, let's work out this question using our Cos ratio. So we write our ratio down in our books first. Cos theta, do you remember, is adjacent side now, divided by the hypotenuse. We write in our information that we have. Cos theta is 26 degrees. The adjacent side, remembering it's the one next to the angle, and the hypotenuse is the longest side opposite the right angle here. And write that information incorrectly, so the adjacent is 40 centimetres and the hypotenuse we don't know is p. Now doing this question, some people find it a little bit difficult. There is a trick way of knowing what to do, and that is simply to replace the p with the cos 26 and the cos 26 degrees with the p. So it looks like something like this. I won't put all there. Okay, and then you can simply put that in your calculator. So let's bring our calculator up. And we get 40 divided by cos, I might need to put that in brackets on this particular calculator, let's clear it. 40 divided by bracket cos 26, close bracket. Let's try again. Try it in your calculator, boys. I'll try it on my other calculator. 40 divided by cos 26, you should get 44.55 degrees. Not degrees, because we're dealing with the measurement here, centimetres. And that's your answer, 44.5 centimetres, rounded. So if you find it easier just to swap these so that the P comes on top and the cos 26 goes down below and you can solve it, you will still get that right. However, let's do it the way I've been showing you in class and doing it mathematically correctly. And if we're up to this section here, we want to get P by itself as the subject of the equation. So here we would first probably see that 40 is being divided by P, so we want to multiply both sides by P. rewrite our information. Then we can see we've got P onto the top line here by multiplying it both sides. Then in order to get P by itself, we need to see what's happening to the cos 26. We can see it's being times, so we do the opposite of that to both sides. And we get P equals 40 divided by cos 26. And can you see that that is exactly the same to what we had over here? P equals 40 over cos 26. So this would be the quick way of doing that. And this would be the more mathematical way. So I would be expecting all of us to do it this way, but if you're really struggling with it, then I don't mind you do it this way, only if you're really struggling. And solving it like we did before, we should get 44.5 centimetres. Alright, draw this question now up in your book. You might want to pause the video. Right, so solving this question, again we want to use the cos ratio because we have an adjacent side to our angle and our hypotenuse. And when we have those three things like that, we know we must use the cos ratio. Cos theta is equal to the adjacent over the hypotenuse. We look at our information, we know that theta is going to be replaced by 40 degrees. The adjacent will be replaced by the x, and the hypotenuse, the longer side, will be replaced by the 15 metres or 15. We want to get x by itself, so we can do our rearranging of our equation. Here we have x being divided by 15, so we must multiply by 15 both sides. And we get cos 40 times 15 is equal to x. Put that in our calculator. I wonder if this calculator will do it properly. Cos 40 multiplied by 15. No, my calculator doesn't do it. Scrap that. Do it in your calculator. Put cos 40 times 15. You should have your calculator in front of you. And we get 11.49 rounded. And it's probably best to put our pronumeral first, so just swap it around to put your answer in correctly. 49 metres, 11.49 metres. Make sure you don't forget those units. This would probably be one of the easiest ones to do. Alright, so going back to the top, we've looked at the cos ratio. We know that the cosine rule is useful when we know the theta, the adjacent and the hypotenuse. And we use the formula as such. We can find the angle, remembering that once we divide, we use inverse cos to find the actual degrees. When we find the hypotenuse, we use the cos theta if we know our angle and our adjacent side. Remembering there is a quick way of doing it, which is just to swap these two things around. P becomes here, cos 26 becomes here. We can just solve it that way. You might want to do that to check, maybe. Do the quick way to check it, but still show me the mathematical thinking through it. And we can find the adjacent side also using the cos theta ratio when we know our hypotenuse and our degrees. And that's probably the simplest of them all. Remember to show all your working and practice all your working in your questions. Tomorrow in class we will be working through questions like these.